In this video, we're going to learn how to configure a network device using NETCONF. NETCONF can be used to configure any network device, an access switch, a router, a firewall, and even wireless controllers. We're going to take the example of configuring a new WLAN profile on a Cisco 9800 Catalyst controller. After a mandatory introduction, we're going to set up our lab. And by the way, in this section we will execute a lot of commands, so fear not, I have pasted those commands in the commentary section of the video. So after installing all the dependencies, we will run some basic NetConf transactions. Then we will be pulling a running configuration using NetConf, which will help us defining our next steps. Finally, we will be sending a configuration blob, also known as our WLAN profile, onto the WLAN controller. And in the end, we will verify that that configuration was actually pushed. This is an instructional video on how to run NetConf in your network and how to run a few basic transactions to a network device of your choice. And our example will take a WLAN controller, but you can apply this on basically any other network device that supports NetConf. And by no means this video is supposed to turn you into a DevOps engineer, but it will hopefully give you a taste of model-driven configuration. Alright, so what exactly is NetConf and why do I need it? NetConf is a management protocol that allows operator to manipulate the configuration of a network device. NetConf was first created to address some of the shortcomings found in SNMP. However, it is very different from SNMP. NetConf is not a proprietary protocol. It was ratified by the IETF and is already in use by major network vendors like Cisco and Juniper. NetConf is a model-based management system, meaning every operation that can be performed over the NetConf protocol relies on models. These models are basically text files describing what can be configured on a network device. The models follow a structure that's explicitly defined within the Yang modeling language. There can be many different models in use by a network device depending on how much configuration can be changed on a particular device. For vendors, models are a way to standardize configuration templates. For operators, models bring a lot more predictability in the way that we interface with network devices. When a network device adheres to a model, we know that we can interface with the device by using that model. This makes the process of managing our network much more predictable than if we were using a, say, CLI-based interface. This also opens a lot more possibilities with regard to automation. And another aspect of NetConf is that it can also be used for monitoring your network. You may have heard the term streaming telemetry before, which is the successor of SNMP. NetConf can also be used for that. However, in this video, we will only talk about NetConf in the context of configuring a network device. For this lab, we are going to do everything inside of a Docker container. So what is a Docker container? Well, just think of it as a very lightweight virtual machine. Only that it's not really a virtual machine, but it offers some of the same benefits without having to install an entire OS on your machine. It only takes a second to get a Docker container started, and you can run many of them on your machine since they only use the resource that they need to perform a task. Here we'll only need one Docker container. Now you do not have to use Docker for this lab. You can do everything in this lab from a native terminal in your operating system. But if you decide to use Docker like I do, just go ahead and download Docker Desktop at www.docker.com. Once you have installed and once you have downloaded and installed Docker, you're ready to proceed to the next step. So now that we have installed Docker on our machine, we're going to go ahead and also download a Linux-like image, which is where we'll be running all our tests from. So in this case, we'll use Ubuntu. This is not the full OS Ubuntu, this is just a container, and it comes pretty bare. Now when you type docker pull Ubuntu, it basically downloads this Ubuntu container from the internet, and as you can see, it is fairly quick. That image was only about 30 megs. So listing my images on my machine, you can see that the Ubuntu container is there. Now let's get a prompt for the machine. Docker run -it Ubuntu bash will actually start the container and get me a prompt. Now if I run ip link show, this command doesn't work. If I do SSH, this command doesn't work. Tells me that I need to install some dependencies. So let's go ahead and update apt-get, which is the package management for Ubuntu. This also is fairly quick. Now let's go ahead and install those dependencies. We will need Python 3, Python 3-pip. We'll also use Vim to some extent, and we'll install some basic networking dependencies like IP root, IP utils, and also SSH. This might take a little while to install, so we're gonna skip through it. And if you get a prompt for choosing a specific time zone during the install, just pick whatever, just pick the default. It doesn't really matter for this lab. Now that we have installed our Ubuntu dependencies or Linux dependencies, we're gonna go ahead and install the Python dependencies. So if you're a little bit familiar with Python, you will know that there are some built-ins that come with Pythons, but there are also many modules that you can install, third-party modules that you can install separately. And in our case, we will be using this small utility called NC client, and that's the NetConf client that we'll be using in this lab. We'll also use pyangbind. This is a package that Python will use to generate Python bindings for NetConf. So here I'm just installing those two Python modules called NC client and pyangbind. Okay, so now we are ready to open a Python interpreter and start doing some NetConf transactions. So first I'm gonna create a small directory. That's where we'll be basing our work from. Let's call this directory NetConf. Okay, so I already have it. Let's move into it, and now I can start my interpreter. First thing to do is to import the NCC client module that we just installed with pip. In this module there is a method called manager, and that's what we use to start open connections using NetConf. I'm also importing constants, which is where I store my password, since I don't want to show it on the screen. And let's go ahead and open a connection with our controller. The target host is basically my network, my WLAN controller, the Cisco 9800. NetConf here use SSH port 830. I will need to input my username, my password, which is my import from the constants file. I have some default SSH setting that I want to override. So again, I will be sharing those commands in the commentary section of the video. And another important setting is the device parameter. NetConf supports different OSs within each category of within each vendor, In here we can actually specify that we'll be talking to a iOS XE OS, which is the OS that the controller runs. So I am missing a parenthesis. That's easy to fix. And okay, so I actually wanted to save this manager connection into a variable called m. Device param is another typo. So you saw that little delay. That means that our NCC client was able to communicate with this controller on IP address 172.28.200.84 on port 830 using those credentials. And this is just basically a simple connection that's established. Now I want to pull an entire config. I want to basically do a show run, the equivalent of a show run at least. And for that, I'm going to create another variable called C. And this one is C. We'll use this manager connect. The function is called getConfig. You can specify that you actually just want the running config. There's probably another way to get the stored NVRAM config, but this running is just fine. Alright, so this takes a little bit more time because this is a full device configuration. Now that we have obtained our configuration, we know that it's only in the memory of the Python 3 interpreter. So in order to see it or to visualize it, we actually need to write this into a file, and that we'll call config.xml. For that, just type in with open config.xml mode write, and this is in context, so we'll name this file f for now. And this is still in memory, so once we do f.write parentheses c, this should effectively write our XML config into the file that we name config.xml. This returns an integer, and that's actually showing that the command succeeded. So now I'm going to go ahead and look into my folder to see if it's actually written to it. Instead of leaving the Python interpreter, instead of exiting the interpreter, I'm just going to go ahead and run a new shell to my existing container. So first I have to find out what the container is named. In this case, docker ps-l shows me my live container. In order to open a new prompt, I type in docker exec -it, the name of the container, and bash for the interpreter, the shell. Now, once I move into my NETCONF folder, I can see that the file is actually written. Let's see what's inside. By using VI, I can actually visualize the file. This is a pretty massive file. It actually contains a bunch of XML tagged items. In this case, we're actually looking at our WLAN profile section. So it takes a little bit to, it takes some effort to get used to, because this is a lot of text that looks like gibberish, and this looks very unstructured, but it is indeed structured. It's just not formatted in a way that's very humanly readable. So here I'm going to look for a WLAN profile that I know exists, that is already configured on my controller. And this WLAN profile is called fpguest. This helps me actually find the model that we'll be using for pushing the new configuration. As you can see, fbguest is basically encapsulated into those tags. Here, more specifically, the Cisco IOS XC wireless LAN WLAN config is our Yang model that we'll be using. The Yang slash name of the profile is the indication that this is a Yang model. So I'm going to go ahead and copy that name and see if I can pull the schema of the controller by using the NC client. So the reason why we actually want to download the schema from the controller is because in order to send a configuration blob to that controller, we need to see how to write that configuration blob. We need to see how it's structured. So that's why we actually pull the name of the model that we want to use. Now we know the name, we can actually pull the schema, look at it, and then make our own configuration blob. Here we can recognize the NC client connector that we created before, and that's called M. We'll use the operation called getSchema. As its name indicates, this is used to get the model from the controller. Similarly here, we also use Python to write the schema into a file. And if that works, we should see it in our NETCONF folder again. So there is also a timeout that I forgot to mention. If I don't use this this NC client manager for a while, it's going to time out and the session's going to be lost. So it's an easy fix. I just have to recreate the connection manager, which is a command we ran before, and this will establish a session and create this object in M, named M, that we can reuse there. So I don't want to type this all again, so I'm just accessing the memory. And let's try this again. Cool. We get a return value, a return integer, which shows a successful transaction. So back on my secondary Docker prompt, I should be able to see it in the folder. Here it is. Sorry. This is the one we want. So that is the model, the schema in Yang format that contains the WLAN profile configuration template. So let's look at it. All right, the Yang file looks pretty good. Now let's use it to push some configuration. If there is one thing to remember here, is that Yang models are not associated with any programming language. This means that in order to interpret a Yang model in a specific programming language, for example Python, we need to use language bindings. Bindings are very commonly used with APIs. In order for us to generate language bindings for our Yang models, we need to use a code generator specifically built for Yang. Here we will use PyYangBind. Now if we look at what's inside the Yang file, we'll see that it's actually very structured, so much so that it can be difficult to get an idea of which part of the config the Yang file actually represents. So if I take a look really briefly, I can see that, for example, there are containers and leaf. Containers not to be mixed up with the Docker container. That's a totally different concept here. It's basically a list of lists, and the leaves are actually variables that can be changed. For example, this leaf represents the SSID, right? And it describes that this is a string. There's a default for that value, which is a blank string, and the description is basically a phrase describing what is an SSID and how it is configured. So if you compare that with SNMP, this has some similarity with MIBs. MIBs is another structure file that describe all the entities and the variables that can be monitored and what are the OIDs for it. Here it's sort of similar, except that it's mostly for configuration, and they're not using OIDs, they're using actually plain text to describe those variables. This file is actually pretty big, so we're not going to go through all of it. We're just going to search which variable are we interested in. And there is a better way to actually search through a YANG file. There are actually viewers that will allow you to view that file in a more readable format. So I'm going to go back to my shell. And for that, I'm going to use Pyang, which we installed before, and which we now know that it's going to be used for generating the bindings. We can also use it to generate a tree-like view of the YANG file. So the command here is basically I type in Pyang. I have to specify what plugin is it going to be using, and the format -f is tree. And then as an input, I put the YANG file that we just saw. So this is basically the same thing that the YANG file, but it's in a tree version, so it's easier to see the dependencies and the actual architecture. So at the root of the tree, you have this module called WLAN CFG data, right? Under that, you have calendar profile config. Under the same level, you have WLAN config entries. So we'll have to pay attention to that one, because this is where we can find our WLAN profile. For example, if I go down lower in the tree, config entry and is another sub branch, and under that branch you have WLAN ID, and here you have the profile name. It is a string. You can also set things like the description, the security setting that's going to be used, if it's WEP or WPA. There's a lot of different values or settings that can be enabled with that. We're not interested in all of it. We're gonna define a very plain, very generic SSID profile, WLAN profile. So we're only interested in a few values here, the WLAN ID and the profile name. This is going to be just enough for us to create our new WLAN. So now that I know the structure of my YANG file, I can actually create an object based on that YANG file that contains the actual parameters that I want to set. So the parameters, for example, profile name would be a string. I'm going to call this profile, this WLAN, I'm going to call it NETCONF WLAN, for example. And the SSID is also somewhere in here. Alright, so I'm probably scrolling over it, but here it is. It is under APF VAP ID data. Here you can set the SSID. So this is the other variable that we'll set. This is what's going to be broadcasted by our access point. Now that we are more familiar with the YANG file and what's the actual structure of it, we're going to use Pyang to generate our actual bindings. So in the same manner than we did before to generate the tree format of the YANG file, we're going to use that Pyang command also to generate a Python binding. So the binding will be automatically generated using Pyang. I have to specify here that I want to I want to generate a binding, so pybind. This is the format. And I have to also specify the output because it's going to generate a very, very large Python library. And I don't want to just have it show on my terminal here. I want to have it created into a file. So I'm going to call this file WLAN binding.py, and let's see what we get. All right, so we get a few errors here, and this is fairly typical. In this example, we're using as an input, we're only using one Yang file, but that Yang also is doing imports too from other Yang files. So it has dependencies, and Python doesn't solve these dependencies automatically. We have to also specify all the Yang files that are needed in order to generate the binding for that specific Yang. So it lists out here which other Yang files are needed. And in my command, I have not specified those Yang files. So this is pretty easy to fix now. But what I need to do is to first grab those Yang files from the controller. So I'm going to go back into my Python interpreter. Now, I don't know if you remember, but previously in the Python interpreter, we have defined a list containing the items, the schema that we wanted to download from the controller. This was the list here that I defined. In that list, there was only one item, which was the Cisco IOS XE wireless WLAN CFG. In here, I'm going to actually use that same list, but I'm going to expand it, and I'm going to add to it the missing dependencies. So I'm just going to paste the name of each missing schema, add it to that list. Alright, so now I have a list defined. I can also use it in the same way that I used it before to download the schema. And because I have a for loop, and because I had written a for loop before, this is going to be easy to do the same thing. Alright, so I get 4 prompts in return. I re-downloaded the first Yang file, but that's okay. Each return integer represents each Yang file that was actually downloaded. So now if I go back to my container prompt and I list the files that are in this NETCONF folder, I should see, and I do see, all the Yang files that were downloaded. So this works great. So now let's go back to our py command to try to generate the bindings and see if this works. The binding was created successfully. Now let's look at what's inside. And we can see that this is a typical Python file. There's a bunch of imports on top, and there's classes and functions under. So it is important to realize here that this file was entirely generated automatically by using Python. This is not something that a human went in and typed in. As you can also see, there's about almost 16,000 lines in this file. So yeah, definitely not something you want to create by hand. But this binding will be used by our program to actually generate the bit of configuration and to also parse the configuration that we receive from a controller. So if I just take a glance at it, looking up there, I will see that there is a class and a method that we'll be interested in. This is the module that we'll be downloading, that we'll be importing in our Python interpreter. So when we import the Python binding, we will then immediately import this module. This module contains the basic functions that are used to create part of the configuration related to the WLAN config. Okay, now we are ready to instantiate our binding and create an object out of it. So I'm going to go back to my Python interpreter and I'm going to import this binding. And more specifically, I'm going to import the module from the binding that we created. So the binding is called WLAN binding. That's the name we gave it. And the module that we want to import is basically the name of the module. And this actually should just work, but what Yang does here is it converts all the dashes into underscore. So I'm converting all the dashes into an underscore, and now the import works. It works because I'm also in the same folder as where the actual binding is, right? Exactly here. Now that it's in our Python interpreter ready to be used, I'm going to instantiate the model, the Yang model. For that, I'm going to create this variable, which I will call model. Now we have basically a blank object. This object does not have any configuration variable in it. And now that we have an object that's ready to use, we can add the attributes that we want. And here what we want is basically a WLAN profile name, a WLAN ID, and also an SSID. So let's get started with that. First we have to know how the Yang file is structured so that we can add our attribute to it. So now that we have a beautiful Yang object in memory, how do we know which attribute we need to populate in that object? And those attributes are basically our configuration elements, the SSID, the WLAN ID, and the WLAN profile name. So in order to know that, we just go back in the tree view that was generated by PyYang before, and we're going to search for those leaf. Okay, so I'm looking here for the SSID string. And by doing a simple string search, I can actually locate the SSID element, which is right under the VAP-ID data tree. This is the first level above the SSID element. I also need to know what's above that, because this needs to be specified in our object. So it's under WNCFG entry, WNCFG entries. Now in my Python interpreter, I'm going to write down my SSID attribute in the same order in which the Yang module is actually listing it. I'm creating a variable that I call WLAN profile. And since my object is already instantiated, I'm just referencing the attribute that I want to configure. Now that I have the attribute name fully listed, I can actually put in a value. And because this is a list, I have to use the keyword add. And my WLAN profile in this case, or my SSID, I will call it NETCONF WLAN, in quotes. Okay, I have added my first attribute into that object. Now let's see what's in there. If I just print the object as it is, I'm gonna get an output with a lot of attributes. So I do a print, and what I get in return is a list of attributes. Those I haven't typed in, but they were defined in the PyYang binding that we generated before. These are basically default variables with default values, and they are added to that object every time I instantiate that. The only thing I did was to change one of the attributes from its default value of blank to netconf underscore WLAN. I'm going to go ahead and add the other two attributes that are needed, the WLAN ID and the SSID. So adding to our WLAN profile the WLAN underscore ID, just make sure you pick an ID that's not currently in use by your controller. You can actually get the list of currently used IDs if your controller has already some config on it. Here I'm just picking a number that's not currently in use. Next, I can add the SSID name, which is under the VAP ID. I'm going to call this SSID NETCONF SSID so that we can find it easily. Alright, so I think at this point we have an object that's ready to be sent to the controller for config. First, I'm going to verify that everything looks okay. So let's do another print. I can see my WLAN ID is set to 5, the profile name is netconf WLAN, and the SSID here is netconf SSID. So I have the three attributes that I wanted to see in my object. Now this object is saved in memory, and before we can pass this data into our NCC client, we need to format it. So netconf used the XML format to exchange data over the wire, which means that we have to convert our Yang formatted object into an XML formatted object. We can actually use Python to do some of that. First, let's use Python to actually convert it into a JSON object. So luckily for us, JSON is a very readable format, which if we print it, we're going to see our configuration object, including the WLAN ID, the profile name, and the SSID, just like we did in our Yang object. Now let's write that into a file. Okay. This file should be exactly the same format as the output that we just had before. Right. Alright, so it looks good. So using Python, I can convert this JSON file into a semi-XML-like file, which is called JTOX. And now using another tool called JSON to XML, I can convert this JTOX/JSON into our final XML format. And there we have it. This is again the same object in an XML view. This is what we're going to send to our controller. So going back to the Python interpreter, I'm going to open this file, the XML file, and send it to the controller using the manager. Oops. I have to re-import the module and probably the constants as well. Alright, so we have a connection established. Now what we're going to do by opening the XML file as a text file, I'm going to call the edit config operation from NC client. The target here we want to actually overwrite the running config or just a section of it. And we pass it the parameter config, which contains the XML file that read. So at this point, we're actually sending that config. So here we're seeing a response from the controller also in the XML format. But this one is much shorter and much easier to understand. The OK that we're seeing here is an indication that the NETCONF transaction went well. Now let's verify on the controller itself whether the configuration was applied or not. As you can see, this is my Cisco 9840 chassis. And I'm gonna see if the profile is indeed configured. I am probably using the wrong command. Oh yeah, small typo on NetConf. And here it is. This is our WLAN profile that we configured using NetConf. No SSH, no GUI, strictly NetConf. The WLAN ID here and the SSID is here. This is exactly what we intended to do, and this worked pretty well. Now we can imagine that any other element of the controller can also be configured using the NetConf protocol. There are so many more things that we can do with the Yang models. In fact, there are probably dozens of models that we could have used as an example. So I hope this video helped you in reproducing model-driven management in your own environment.